Okay, the production function is a relationship among three variables and the level of technology. Okay, where technology is the knowledge or know-how, just what we know about how to produce a product, how to combine the inputs to produce a product. Okay, so this shows us Q is the maximum amount of output that can be produced with capital K and labor L. Okay, and the technology is implicit in this functional relationship. In this, there's a short run and a long run production function. In the short run, the short run is a period of time when some factor of production is fixed. Okay, so the notation the book uses is a star, a superscript star to indicate the fixed factor of production. And typically, the factor of production that is fixed is capital. Okay, capital is the plant, okay, machinery, equipment, okay, things that you can change the level of, but it takes more time than adding and subtracting workers to the production process. Okay, so if a big chunk of your capital is a factory, it might take a year or several years to build a new factory or expand the existing factory. Okay, in terms of equipment, it might take weeks or months to order a piece of equipment and have it delivered and have it be in operating condition so that you can increase your production because you've increased your capital input. Okay, so this period of time, it differs for different businesses. There's not a number that we can say the short run is 3 months and long run is anything longer than 3 months. It differs for different industries. Okay, so you imagine the automobile industry. It takes longer to get from the short run to the long run than it does for a hot dog stand on the side of the street. Okay, so the long run is the period of time when all factors of production are variable. Okay, when you can change all of your capital decisions. Okay, so in the rest of this lecture, and the rest of the material that we'll cover in Chapter 5, we are going to focus on the short run, okay, and mostly when capital is fixed. And there's a practice problem in Chapter 5 where the scenario is that labor is fixed. We've got, I think it's, there's labor contracts and we can rent different levels of machinery. Okay, so in that problem, that practice problem, you analyze it the same way we're going to talk about things in this chapter, in this lecture, but you just switch the variable and the fixed input. Okay, so in a short-run production function, there's different ways of measuring productivity. Okay, the total product, this is the maximum level of output. So that's just Q that can be produced with your inputs. Okay. Then the average product is measurable by business firms. Okay. You can take the average product of labor, you can figure out how much output you've produced and how many worker hours you have employed and figure out how productive labor has been. Okay, you can do the same thing with capital. Take the amount of production and then divide by some measure of capital that you have. It might be the number of machines. Okay, or it might be how much you have used those machines. Okay, marginal product, marginal meaning additional, is more difficult to measure for a business firm. But marginal product is the measure of productivity that we will find that informs our understanding of the business behavior more than the average product. More difficult to measure, but more informative. Okay, the marginal is the change in output divided by a change in labor. Okay, so imagine that you have a lawn mowing business and you have a lawnmower and a weed eater and one worker, and the worker can mow 5 lawns. If you add one more worker and the number of lawns that you can mow increases to 8, then the marginal product of labor is equal to 3. Okay. And then the marginal product of capital is similar. Okay, but we have the change in capital here, and we're operating in the short run. So typically we won't be working with the marginal product of capital in this lecture, but it's equal to the change in quantity produced divided by the change in capital. Okay, so here's measures of productivity in action. So here's a simple numerical example. So imagine we've got a production function where we have 5 units of labor and 10 units of capital. Okay, so just implicit, we just have an implicit functional form here. And we have 150 units of output. Okay, so what's the average product of labor? What's the average product of capital? Well, the average product of labor is output, 150, divided by 5 units of labor. So that's, we have 30 units of output per worker. And then the average product of capital, that should be a K, is equal to 150 divided by 10 units of capital and 15 units. Units per capital, per unit of capital. Okay, now imagine that we've added one more unit of labor. Okay, so now combined with 10 units of capital, we have 6 units of labor. And when that additional worker is added, we have 155 units of output. So compute the marginal product of labor. Okay, so the marginal product of labor, the change in output will be 155 minus 150, and the change in labor is 1, so that the marginal product of labor is 5 units per additional worker.